Hello, I'm Switch.
And I'm an LED. Know what that is?
Yeah, that stands for light emitting diode.
No, it stands for light emitting diode, my friend. You know, those annoying little lights that keep blinking on and off and driving you absolutely crazy.
Well, actually, in the green age, LEDs are much more than that.
I particularly hate the little buggers on my clock. Oh.
Yeah, LEDs consume 1/4 of the electricity of fluorescent lights and last about 10 times longer.
And then there's that annoying buzzing sound I'll have to deal with. Oh, God, I hate my clock. I hate mornings. Hate them.
LEDs are only the beginning. Technology is evolving at a tremendous rate and pricing is falling dramatically.
I can fall dramatically.
In order to save energy in your building, you really need to understand where that energy is being used. And it's kind of interesting if you do a circle graph of the energy in your building. I just want to focus on commercial right now because when you get into industrial buildings, they're really kind of a cat of their own, and you could have a lot of equipment that could really stray the results of the circle chart. But on a commercial building, typically 40% of the energy that's used in that building is lighting, followed up by fan power, to move the air through the building for air conditioning and heat, ventilation. 10% normally is ventilation outside air, and the remainder is boiler, refrigeration, computers, things that people normally use in the building, elevators. So I think that's why you see so much focus on lighting, because lighting is really the key factor in the building. And in a little while, Lou is going to talk about harvesting some of the lighting energy. Lighting always bothered me as an engineer, and the reason is, if you look at the power coming into a building, it's 25% efficient by the time it hits the building. The generation plant puts it out at about 35%. A lot of the energy goes up the stack at the energy plant where the power is produced, and the losses during the distribution to get you to the building are another 10%. So you're 25% by the time you get to the building, and then you plug your light in, and your light's about 10% efficient. So 10% times 25, you're about 2.5% efficient. So obviously there's a lot of room for improvement. And I think the LEDs that you're going to hear a little bit more about today are a big advancement. Part of the inefficiency of lighting that also bothers me as an engineer is that inefficiency converts to heat. So if you have a light that's 20% efficient, 80% of that inefficiency goes directly to heat. That heat then goes into the building and it has to be cooled, and that's a load on the air conditioning system. So again, there's a lot of room for improvement in that area. We heard Representative Wansack talk about deregulation. It started in '94. The caps are coming off in Pennsylvania in 2011. PP&L will be deregulated January 1st of 10. So saving energy is going to become a big deal. The past 10 years, there's been a green building movement going on in the country. Everybody's been swept up by it. It's a good thing. It led to the development of the leading edge environmental design, point system by grading buildings on how efficient they are. The code guys are now putting the crosshairs on LEED. I think California is probably going to be the first state in the country that's going to mandate, probably in 11, that LEED will be the law of the land. And that's a good thing. So looking at your building, what are the sweet spots where, on the mechanical side, you can save some energy? First of all, motors. If you have an older building that has older motors in it, those motors are probably not high-efficient motors, and you need to take a look at your motors. Sometimes replacement of a motor with a high-efficiency motor has a reasonable payback, especially when the rate caps go off. Variable speed drives on motors. Motors turn 1750 RPM, typical motor. You put it on a fan. Fan is using 20% of the energy in a building. Well, the fan laws are interesting. Fan laws work on the flow of air. If you reduce the flow of air 10%, the reduction in horsepower actually is on the square of the ratio. So 1.1 squared is 1.2, so you have a 20% gain in horsepower if you slow your fan down in the building 10%. Well, you don't need it running full time all the time unless you're at peak load. So peak load winter, peak load summer, and the shoulder season, spring and fall, there's a lot of room to pick up some energy savings by slowing the fans down. Same thing on pumping in a building. the hot water distribution system. A lot of buildings have chill water distribution systems. By monitoring the pressures in the systems and the flow requirements and reducing the flow of the fluids in the building, there's a lot of room for saving energy. Transformers in a building. Most commercial buildings have power coming in, 277 to 480 volt. It's knocked down to 120, 208 volt, typically for lighting and for power for the computers. Those transformers, if they're older transformers, are probably not high efficient transformers. And again, changing them over, sometimes it does make sense. A lot of times the transformers are way oversized. You may have a 25 kW load with a 100 kW transformer on it. That's not a good situation. You're probably losing an extra 5% of the power with that transformer setup. So sizing the transformers to correctly match the load is an important issue. Energy management. Some simple things, just like, and these have been around a long time, but it's amazing the number of buildings that you go in and just see a standard thermostat on the wall. Programmable thermostats, they make a lot of sense. Going one step beyond that, microprocessor technology really has taken over building control and management. Putting a microprocessor system in your building to start the equipment in the morning, you could actually start the ventilation a little bit later, shut the equipment off just a little bit early, modulate pumps, modulate fans to save energy. The cost of digital control systems has come down tremendously. Makes a lot of sense. Ventilation in buildings, especially schools, public buildings, a room like this where you have high occupancy and high ventilation loads. CO2 monitors, monitoring when we breathe out, we give off carbon dioxide. Measuring that carbon dioxide and then reducing the amount of outside air that we bring into the building